Hi there. So with these examples, they want us to show if the two triangles are congruent or not. And there are quite a few postulates or rules that we are allowed to use to show triangles are congruent. Here they are. There's 5 different postulates. It's all based on what information we're given in the triangles. So the first one here, you can see that all the triangles have 3 side lengths marked. Let me grab my pencil. There we go. This is gonna work. I hope. So a lot of times I'll label the diagram with what is marked, and then the postulate just kind of jumps out at me. Look, it's SSS. That means we have the side postulate. Here we have a side marked, an angle marked, and a side marked. That's the SAS postulate over here. See? So it just kind of depends on what information you're given that's showing the triangles are congruent. So remember, we can match up markings. So this is one tick mark here, matches up with this tick mark. That means those sides are congruent or equal. So like this could be 2 and this could be 2. So let's look at the examples you sent. It says match the picture to the reason that would prove the triangles are congruent. And this is a really big hint here to look for any additional information that you're allowed to mark in the picture. So see this one, we have some markings already. This curved marking here shows the angle B and D are the same measure, that they're equal. Also this angle up here. But check this out, they tell us that C is the midpoint of AE. Remember what midpoint means. It means it's in the middle. So if something is in the middle, if C is right in the middle of A and E, then we know these pieces must be the same. So we're allowed to mark them congruent. And I just picked one tick mark because it hasn't been used yet. You could do anything really. So now let's see what we have marked and which postulate jumps out at us. We have an angle marked here, an angle marked here, and a side marked here. So this is angle, angle, side. One thing you want to be super careful about is you wouldn't want to start here at angle B and go this way. We wouldn't say angle, side angle here because then you're skipping some information. You have an angle, side angle postulate, but you see how this side doesn't have anything marked and this angle doesn't have anything marked? So it's like we would be going angle, side, angle. So you want to start somewhere and then go to the very next closest marking. So if I start at this angle, then I would go to that angle because it's the next closest marking. If I started here at this angle, then I would go to that angle. Angle, side, angle. All right, the next one, again, this important information here, it tells us that CB bisects these angles. So that means CB cuts the angles in half. Bisect, bi meaning two, so it cuts it into two equal pieces. So this line down the middle is cutting these big angles in half, so that means they're equal. Let's label them equal. So CCA is cut in half, that means these little pieces are the same, and then DBA, so these angles are the same. Then also, there are two other things you can always mark. Always mark. Whoops, other. You can always mark a reflexive side. Reflexive meaning like reflective if you look into a mirror. So if we had a triangle and it was stuck together by this side, we can always mark it because it's essentially a part of both triangles. If we were to separate them, you would see that they share that side. So we can always mark a reflexive side. I tell my students to think of two pieces of bread with mayonnaise in between, and you pull the pieces of bread apart and you have mayonnaise on both sides. So it shares the side, so we can always mark that congruent. Okay, now we have angle, side, angle. The angle, side, angle postulate kind of jumps out at us. Oh, the other thing, remember I said there's two things you can mark. The other thing you can always mark is the, vertical angle. So if you have two I want this to work now. There we go, maybe. Okay, if you have two triangles, kind of like this is one example. These angles are right across from each other. They're vertical. They share a vertex. So you're always allowed to mark them equal because they are. Okay, here's another example, number 3. Here, these two triangles are stuck together at BC, so that's our reflexive side. I chose 2 tick marks because 1 tick mark is already being used in the diagram. And whenever we have right angles, we should always think about a right triangle and hypotenuse leg. So remember, across from the right angle is the hypotenuse. So here we have a hypotenuse marked and a leg marked. This is HL. And you can always reference back to this diagram if you need to. There's HL down there. All right, what's next? These are fun. Number 3. Did we already do number 3? Yeah, I think it's the same one up here, right? Yep. So let's do number 4. Let's see, what do we have marked? We have a side, and an angle. We have a side, and an angle. We also have ASS. Now, this is like mildly inappropriate, but I always tell my kids there's no ASS in math. I write it once and then I cross it out. There is no ASS postulate. You can also see there's nothing in the list that would match SSA or ASS. So this would be none. Number 5. Ooh, we have our vertical angles here. So we know that this angle is also 90 degrees. Those are congruent. And it also tells us that BD and AE bisect each other. So if they bisect each other and down the middle, then we know each of these pieces are congruent. So we have, hold on, I marked that wrong. Let me get this eraser. That would be these pieces are the same, right? And these pieces are the same. So we have side, angle, side. Side, angle, side. If you wanted to write a congruent statement, we could say that triangle ABC is congruent to triangle what? We have to go in the same order. So A to B to C. So you see how it's no tick mark, 1 tick mark, 2 tick marks. So we're going to start no tick mark, 1 tick mark. So it has to go EDC. I'm sorry. Yeah, EDC. We have to go in the same order of the tick marks because the congruent parts will match up. All right, the last one here. Ooh, we have a stuck together triangle, so we know we can mark that because if we were to separate the triangles, they would each share that side. So now what do we have marked? Side, side, side. Side, side, side postulate. And that's it. Let me know if you have any more questions.